those rest of your work, don't worry about it today. Not important enough. Okay. But we'll go over it together. So, number one, who can tell me how I do number one?
You just distribute the 5, multiply it by 2, and then do 2 to the 5th power.
2 to the 5th power, and what else? What else happens?
So then it would be 10x.
2 to the 5th, x to the 10th, which is the same as 32x to the 10th. That's right. How about number 2? What do we do on number 2? Yes.
You multiply 12xy times 7x to the 5th y squared.
That's right. You can do that.
And then multiply the denominator the same way.
You can do that also.
Yeah.
There's a faster way of doing this one. What we can do on this case is cross-cancel. You ever hear of cross-canceling?
Yeah, like
so
you x out the y.
I can take care of the 7s right away. And the 12 and the 4 becomes 3 and 1. And the x to the 5th and the x to the 4th will become just plain x. So what I'm left with, and we have also y over here. So I'm left with is an x here, 1x there, and y squared. X squared, y squared. Now we can do it exactly the way you just told me. We can multiply it together and we can start canceling things out. But if you can see these sorts of patterns, it would be 3x, thank you. So it would be 3x squared, y squared. So if you can see these sorts of patterns forming, it will make it faster and easier for you to do problems like this. Now, are number 3 and number 4 the same value? Do they have the same value?
No.
Yes, they do, but number 5 doesn't. So this is 16, and this is 16. See, that's the difference between putting a negative in parentheses and a negative outside of parentheses. So in this case, this is negative 16. Because what happens here is that we have 2 to the 4th power made negative. Over here, we're multiplying 2 to the negative 2 to the 4th power, which means we're doing negative 2 times negative 2 times negative 2 times negative 2. Important thing to remember, 3 and 5 are not the same thing. Now, that's with an even power. With odd powers, it doesn't matter quite so much, right? What's negative 2 to the 3rd? Who can tell me?
Negative 8.
Negative 8. And what's this?
Negative 8.
Negative 8. So with odd powers, it doesn't matter quite so much. With even powers, it does. And this is just 2 to the 3rd power. This would be 8. So like I said, everybody, we need some notes because we're doing a new topic, or a relatively new topic today. So everybody should have something else to take notes with. So, this is a very important idea. The reason why we invented this system to do square roots is because you can't program every possible square root to a calculator. That's pretty much the reason why we invented this system to begin with. Because while you can do 8 to the 1/3 power to calculator, or 16 to the 1/4 power, we don't have 4th roots in the calculator. We do have cube roots. We don't have 4th roots in the calculator, or 5th roots, or 6th roots. So what happens is, we make those square roots, those roots that are higher than 3, and also lower than 3, we can make them into powers that are to the 1/2, for example, or 1/3, into fractions. So what we say here is that whatever root is out here becomes our denominator of the exponent of that number, and whatever power is in here becomes the numerator of that. And if you think about it a little bit differently. So let's say we have the cube root of x to the 3rd. Well, the cube root of x to the 3rd is the same thing as, we take the x outside of the root, 3 becomes the denominator because that's the thing on the root, and then 3 becomes the numerator. This is just x. And you can see the cube root of x cubed is definitely x, because the cube root of anything cubed is itself. So this will be x to the 1st power, which is x. So when we do a problem like this, how would I rewrite this as a rational exponent? Who wants to be brave? Okay. Well, what's the root out here is the 3. Does that go in the numerator or the denominator of the exponent? Denominator. That's where it goes. So we'll take the x out of the root, and we'll put 3 in the denominator. What goes in the numerator? 5. That's exactly right. And that is really just exactly how you do these. Now, in some cases, we can simplify the root a little bit. For example, I'm going to show you here. 5th root of 32. Well, that's the same as the 5th root of 2 to the 5th power squared. What's the 5th root of 2 to the 5th power?
2.
2. So this is the same as 2 squared, which will equal 4. And there's lots of little tricks we can do with these sorts of roots like that. We won't get too far into that today, but there are situations you can do that sort of thing. So for example, a 4th root of 16, is there a way I could rewrite that that'll make it clearer what the answer to this is?
16 to
Six-
1 over 4.
Well, that's true, but how about 2? What is 16? It's 2 to the what power? 2 to the 4th power, right? Everybody knows 16 is 2 to the 4th power? Well, that can be written as 2 to the 4th root. Now we can rewrite that a couple different ways. We could rewrite that as 2, or we could rewrite it as 2 to the 4 over 4, which is the same thing as 2 to the 1st, which is 2. Either one of those is fine. But either way, you get 2. And here's a really tricky one. The 4th root of negative 81. So, this is a really important rule concerning roots. Every even root acts with negative numbers like a square root. Remember how when you were doing negatives, the negative square roots, you get an imaginary number?
Yeah.
Well, this is also imaginary. This is an imaginary number. This is not. There are no real answers to this. So when we have negative 81, we can rewrite this as negative 81 to the 1/4. Negative 81 to the 1/4. But that doesn't equal anything. No real.
Oh, that's what happens to the.
Okay. Real.
You gotta press the button, different color.
Oh, okay. Real solution. There's no real solution to this. Yes. Yes, you may. So, yes. It's because it's a negative. We know that, for example, what's the square root of negative 81? Do you remember?
3i.
It'd be 9i. And this would not be 3i. Yeah, the square root of negative 81 would be 9i. It's an imaginary number. Well, 4th roots and 6th roots and 8th roots and 10th roots and every other even root are treated in that same way. Odd roots, you can get negative answers for odd roots, but you can't for even roots. It doesn't work. You can't multiply any number 4 times together and get negative 81, any of the same number. Can't be done. It's like everybody's done taking notes. Okay. So, again, this sort of thing also works in reverse. So if we have x to the 5/3, we're going to take that 3, and we're going to put it here, and we're going to take that x to the 5th and put it in there. And it's important to remember a little bit that this is the sort of thing. This is the sort of thing you can do with these. If you remember your laws of exponents, you know that x to the 5th to the 1/3 power is equal to x to the 5/3 power, because we multiply those things together. Well, that's pretty much what we're doing. We're taking that x to the 5th and we're putting it inside a cube root. It's exactly what we're doing. So similarly down here, who can tell me how I rewrite this one? Anybody? Yes.
612 squared to the root 7.
That's right, the 7th root. We'd have the 7th root of 612 squared. Now it's possible we can simplify this, but I haven't the faintest idea. And we would naturally square 6 to the 612 to the second power. Anybody have an answer for that? I can write on the board. 612 to the second power.
374,544.
So 370. Say again.
374,554.
So this is the 7th root of that. I have no idea what the 7th root of that is. But I have some idea what the 5th root of negative 32 might be. Now, remember, we can't find a real answer for a even root of negative numbers, but we can find one for an odd root of negative numbers. So let's rewrite this a little bit. Let's rewrite it as negative 32 5th root. Let's write it like that. What is the 5th root of 32? We did that a couple minutes ago. You remember that?
2.
2, right? So what do you think the 5th root of negative 32 is? Negative 2. So this is going to be the same as negative 2 squared, which will give us 4. And keep in mind, the 32 is in parentheses. This is not equal, it's not the same thing as negative 32 to the 2/5. That is not at all the same thing. What this is going to give you is negative 4, because the negative sign stays out front. It doesn't get affected by the exponent. Yes? Say again?
Can you do the second one again? I lost.
Yes, I can. So what I did is I took this denominator and I put it over, took this denominator and I put it over there. And that became my root. It's a 7th root. And then what I did is I took this 612 squared and I put it inside the root. And then I actually calculated 612 squared.
I thought it was like two
That's
separate
help.
numbers. I thought it was like 374 and 554.
Oh, I understand. No, that's just one number. Yeah. So, any other questions on this part? Okay. So finding the indicated real nth roots. So first of all, we understand that this is true. N must be a natural number. Everybody remember what a natural number is? They're your counting numbers. So roots can't be like the 7.5th root. They have to be 1, 2, 3, 4, 5, 6, 7. They have to be a positive whole number. So for this, n has to be a positive whole number. And remember, if you have a root like this, and let me show you something. If you have something like, 7 to the 1 over 3.5 root, that's the same thing as 7 to the 2 over 7th root, because those fractions are equal. And then what you'll get is 7th root of 7 squared, which is the 7th root of 49. 7th root of 49. So if you have some sort of decimal or fraction in your denominator, make it into a natural number. Probably won't see a lot of that, but important to know. So again, if n is odd, you get one real root. And if n is even, is a is positive, you get 2 real roots, and if a is negative, no real roots. And that's what we're talking about using variables for this. So we're talking about using variables. Because as you're well aware, with a simple square root, if we took the square root of 81, that's 9. But if we said the square root of x squared equals 9, it could be, x can be plus or minus 9. Everyone remember that? Okay, so that's what we're talking about. We're talking about two real roots here. Yes?
Oh, can I use the pen?
Yes, you may.
Thank you.
So let's see. Yeah, in this is exactly the situation that we're talking about here. So if we're being careful, this is 8. This is not 8, negative 8. This is going to be negative 3 over here. And this is going to be nothing. This has no real roots. Like we saw before, this has no real roots. So over here,
Excuse me.
yes.
So if it's an even number and it's like negative, then it's negative.
Yeah, if it's any sort of even root and it's a negative, there's no real roots.
Okay.
That's correct. So let's see. So let's see. We have this is going to be written as cube root negative 125. Anybody know what the cube root of negative 125 is? Anybody think they know? What's the cube root of 125? Anybody remember that one? It's 5, right? So the cube root of negative 125 will give you negative 5. Give you negative 5. It helps in this case to remember your cube roots. If you remember go in the way back machine and to remember the cube roots. Main cube roots you want to remember are 1, 8, 27, 64, 125, and 216. That's up to 6. So you want to type those in your calculator and remember those because they'll come in really handy. Okay. So over here, this can also be written as negative. It's also be written as attempt number 3. This can also be written as negative 125 to the 1/3 power. It's the same. It's the same thing. Now over here, who can tell me how to write B? Who thinks they know how to write B? We have n as 4, right? So look up there. Where do we write our n? That's right. We write it in the denominator. We can write it there. So 16 to the 1/4. It's also the same as the 4th root of 16, which is going to equal 2. It's going to be 2. Yes. Yes, of course. And then when we have the 4th root of negative 31, is there a 4th root of negative 31? Can there be an even root of a negative number? No, right? Because this is the same as the 4th root of negative 31, or negative 31 to the 1/4, which equals nothing. This has no real roots. That's what it means. If A is negative, no real roots. And it's important to realize, as I said, it's really only when we use variables that we're going to get the 2 real roots. I know it says that up there. I know that's confusing a little bit. I understand that. I'm sorry. But the reason why that's true, you have to keep in mind that that's true when we're using variables. But when we're using constants, the way you graph a square root function, does everybody remember from first semester what a square root function kind of looks like? It looks, if you remember, it looks a little like this. Remember, that's what a square root looks like. Everybody kind of remember that from first semester? That's what it looks like. Well, you notice that doesn't have any negative answers, right? That has no negative answers. But the square root of x squared can have negative answers. Because if you're putting a number in there and you're squaring it, you can have negative answers. And this is true when you get to higher power roots too. This is a little look ahead. We're not doing this yet. But this is true when you get the higher power roots to a certain extent, because if you're going to square -7 in there, you might be able to get 2 answers from that, because you started with -7, so you have to come up with -7, for example. But I won't get too deeply into that right now, because that's for later. For right now, your homework is on the board. You have homework 13 through 34. We should get started on that in class today. So I think we still have one.